This is a Rockwell hardness testing machine. This is one of the three hardness testing machines we generally used in practice. In the front, this is the test pieces, copper, steel and aluminum is given. Here is the chart provided on the surface of the machine, which tells us for which hardness we are supposed to do. This is the platform, and it is a works as a screw jack with the handles which can rotate a clockwise anti-clockwise direction to lift this table up and down as like our Brinell hardness testing machine. Here inside this cavity we fix our indenter itself, and this is a collar which keeps the indenter safe from the outside heating or something. This is the indenter. One is steel. This one is pyramid indenter. This one is 1 by 1/16 inch hardened steel ball indenter. This is the workpieces, copper, steel, and initial was aluminum itself. These hard pieces are different in size than that of vinyl hardness itself. Here is the visor, and above the visor there is the platform over which you have to place our workpiece, and dice should be moved clockwise or anti-clockwise to move up and down of the workpiece itself. Here is the position where the load is shown, where you have to set the load. Here 60, 100 and 123 loads are available. Here just by means of a movement, we have to fix the load itself. Next, this is the chart provided on the machine, which gives us the, according to the type of the workpiece, the load applicable and the type of indenter which you are supposed to apply. Again, let us start. The front view of Brinell's Rockwell hardness testing machine. You see just 1 second. So much people are. This is the indenter itself. This one is 1 by 16 inches steel ball indenter, and this one is let people come back and repeating this thing again. I'm repeating the experiment once again because I could not tell anything due to for giving the attendance. Now, this is the Rockwell hardness testing machine itself. What we have here, you see the test pieces on the bed of the machine. This is the chart which it will come later, showing you the for showing how to select the indenter as well as the load for indentation itself. Here is a platform which is fixed over the top of a screw jack, which can be moved clockwise and anti-clockwise to move it up and down. Over this platform, we place the place the blocks for testing machine itself. Here about this capacity, we fix the indenter itself. This is the indenter. First one is the 1 by 116 ball, and second one is the hardness taking. Is the diamond pyramid indenter. Next, aluminium, steel, and aluminium is the test piece itself, which is used for hardness testing machine. Hardness testing. In the hardness, different tools are indenters are kept. Here we have showing that device, screw jack device once again. Then I am going to this is the place where you have to adjust the hardness, load up for the hardness. Here you have set the 60 kg loads. By moving it, you can set 100 120 kg load itself. Next, here is the chart which tells you for your particular type of item which one, what will be the load, indented load, and what will be the correct indenter, and what will be the block itself. Next, let me go to the another share, another it's stop share. Just let me have. Next, let me go to the share the another hardware system. Here the machine. Let me start this hardness testing again. Here we are starting the hardness testing itself. I have pressed the workpiece, which is possibly the aluminium block, which is kept over the table, and it is lifted by rotating this handle, the screw jack handles, to go up so that it touch the indenter fixed inside it. Next, we didn't stop the moving the handle of the platform. We'll go on moving it so that it can be these dial gauges can be adjustable accordingly. Next, as I'm moving up the indenter, this is going up. This is dial is moving, and it is reaches this point set for the big one and for the red point for the smaller one. Now the machine is ready for the testing the hardness itself. There is a small point where the small halo will go, and big point the halo is there. Now this is the load 100 kg where you are where I have set the machine, and by means of rotating this handle on inside the clockwise direction will actuate the load. Just you rotate this, you have actuated the load so that the indenter is now indenting the test piece itself. The indenter will move unless the indentation is complete, and it will stop when the complete indentation is have taken place itself. Now it has stopped again. Now we have to withdraw the loads by rotating the anti-clockwise direction. We have just moved it in the anti-clockwise direction and released the load. Then the pointer came back to a position which is given by the hardness testing machine. Because there is no load and indenter is only pointing up to the sensation of the rod itself. I'm repeating it again. This is the experiment which we have started. We have placed the test piece over the platform. We are moving by the movement of the screw jack system. The platform goes up, and Initially, it just the indenter here. Now we have to adjust the dial gauge kept on the machine itself. To adjust it, we have to move we have to lift the platform once again. Just I am showing you at this moment. We'll move it anti-clockwise direction. It will go up. Now it is going up, and this dial, the big indicator of the dial is also moving and set on the set point here for the outer dial, and to the red point in the inner dial itself here. Now the machine is ready for setting the work, doing the work. Next, we have set it accordingly, 100 kg as per the chart tells us. Then will actuate the load by moving this actuator handle in the clockwise direction. I am just moving it. Yes, moved, and load is actuated and indenting the workpiece. Thus, as we are indenting the workpiece, the dial is showing that the load is being released, and the dial will move so long the indentation is complete, and it will stop when the indentation is totally completed by itself. Here it is now stopped here, so it is sure that indentation is complete by the dial itself. Next, we have to release the load by moving the handle anti-clockwise direction. We have moving it, and the load is released to a certain extent, and the indenter goes back to this way point where Rockwell C scale, as per Rockwell C scale, it is reading 72. This is the required Rockwell hardness of the machine itself. This is the process of doing the Rockwell hardness test. Now, let us go for the manual. This is the manual of Rockwell hardness testing machine, which I am explaining as desired. Rockwell hardness testing machines are generally designed for manufacturing the hardness of metal alloys of all types, maybe metal hardness or metal medium hardness, maybe high hardness, soft, whatever, but whether flat, round, irregular in shape, everything can be tested here. Thus, this Rockwell hardness machine is the universally applicable machine, and it is most widely used hardness testing machine in any sort of laboratories or workshops or companies. You can test soft or hard, and flat, round, or irregular shaped material in the hard material for to check its hardness. But one thing you have to ensure, you should have a point which is perfectly flat over the surface of your workpiece where you can engage the indenter itself. Otherwise, uneven surface cannot be checked by the Rockwell hardness. You have to make at least a point over the surface itself which is perfectly flat, where you will engage your indenter and supported by the load, and you will adjust the load accordingly. These machines are very simple in design and easy and quick to operation, and extremely sensitive and accurate itself. This test is based on the indentation of a hard tip on indenter into the test piece under the action to consecutively apply load, minor and major final load. What we do here, I have just you have witnessed the machine. First, we have to place the indenter according to the chart set on the machine. Means the chart tells us, as per your uh, workpiece or test piece, what is supposed to be the uh, load, what is supposed to be indenter load, and what is the type of indenter here you are supposed to use. There are two types of indenter we are use. One is known as 1 by 16 inches steel ball diameter steel ball indenter. Another is diamond pyramid indenter. And where these indenters are applied is given on the chart which we have shown in the side of the machine itself. First, you have to add you have to you have to keep your workpiece over the table itself. You will move up by rotating the handles of the screw jack of the table, and table is goes up and it will touch the indenter, and thus you have applied the minor load where there will be no change in the no change itself in the dial gauge itself. But here, unlike other hardness testing machine, you will not stop there. It will move on rotating your dials so that the dial gauge moves got engaged and ultimately reaches a position, or the bigger uh, bigger arrow or bigger cut points will locate on the set point, and small points will locate on the dark red point on the small scale. When both these points are set together in the respective position, then you say that initially the machine is settled and minor load is applied over the workpiece itself. Actually, you are not applying, you are just only adjusting the machine itself. Now, what is the principle? Have, what is the principle? It is an indentation hardness test, means we have to check the hardness of a particular workpiece by making indentation over it and checking the dimension of the indenter itself. You see, the hardness testing machine process are maybe different in name, are essentially same. You have to produce indent over the hard over a test piece by applying a known indenter indenter and test piece are specific for machine to machine as per the design and size of the machine, and load is also specific for machine to machine as per the design of the machine. These two, so specifics and load, can check the test from and change from machine from process to process of hardness. Next, you'll apply the load. The method of application of load and amount of load is different from machine to machine here itself. Here we are just rotating a dial on the front, and we have only three loads, that is 60, 100 and 120 kgs load available there, and you have to select any one of them and apply it. Now, we have just have told you a diamond sphericonical indenter where whose apex is 120-degree and 0.02 millimeter radius for indenter or penetrator for handmade hard metal or hard steel ball indenter. Another one is hard steel ball indenter, 1.5 millimeter diameter or 1 by 16 inches small diameter, under and perfectly polished under specific condition to the into the surface of the material under two corporations, under testing two corporation, and to measure the difference in depth of the indentation under the specified condition of preliminary and total test force. In Brinell hardness testing, we have checked the diameter of the indent. Here we will check the depth of the indent by means of the dial gauge shown in front of the machine itself. We don't have to use any separate chart for checking the hardness. Here, this hardness will be directly available for the dial gauge itself. That's why Oracle is a fast or quick and accurate testing machine. The description of the machine is like this: the hardness tester, with body is cast iron, made of cast iron. The enclosed design protect the internal parting walls from detrimental dust and external elements. Actually, it is the structure of the machine is fully covered by different sheets to prevent the direct hardness and any sort of damaging on external effect over the intricate part of the machine itself. A double below is provided over the main screw to protect it from dust, and the basic system for applying the load is a system of weight and lever. This weights activated under a hydraulic dashpot itself, which is under the machine itself, and by rotating the handle, you are either releasing it or engaging it from the work from the load itself. When you rotate the actuating handle rightwise, you are releasing this uh, releasing a dashpot, so that total load is applied over the load you see you have set is applied directly over the uh, or the workpiece itself. And you have to keep this is under pressure for few minutes and then release it, which transmit the pressure on the plunger then to the workpiece for the determination of hardness value. The weight first you have to go to the plunger and then to be transmitted to the workpiece to determine to for the determination of whose hardness value you are determining. A clamping device enables the tight clamping of the work instead during the test. Here we have not used any such clamping method because we are a regular test piece which we are testing. But other difficult critical test may require clamping over the bed itself, so that under the action of the load, the test piece should not move at all. Uh, the dimension or capacity of the machine is like this. rest height is 125 millimeter, and depth of throat is 135 millimeter itself. And maximum growth screw base case is 215 millimeter. Diameter of the machine base is 115 to 425 millimeter itself. Net weight is 67 kg. Now, here in the chart given on the manual, there are a chart which is provided on the side of the machine. Is also provided here to prevent to tell you what should be supposed to be the hardness itself. Now here we are applying 60 kg. Here we are applying 165 40 100. Here we are applying 150 kg or a kg load here. And our machine doesn't have this 187 and 100 250 kg loading system. Here, the indenter we are using for the first for 60 kg diamond, 120 diamond, for the second 100 kg ball, 1 by 160 inch diameter ball, and for third or 150 kg it is as high as diamond 120 machine itself. The scales of check we have seen one black and one red scale, and this is selected accordingly, the C scale or B scale or A scale. The pointer position dial always you have to set accordingly. Dial to be used. Yes, you see black dial for this 60 and black dial for this 150 and red dial for that 100 to 100 ton. What are the different types of material? We can check this type with this setting. The steel and shallow case hardening steel is used in the with the used to check with 60 kg indenter load with the diamond 120 indenter and with dial black dial and with scale A, or steel stiff soft steel, not hard steel like here. Malleable copper, aluminum, compatible software items are being used with test piece 100 kg, with the indenter load 100 kg, with ball 1 by 16 inches ball diameter, of steel ball diameter, highly polished, and the dial to be used is supposed to be red, the inner dial, which is red inside. Third, the black dial. Third, steel, hard cast iron, deep case hardened steel, all the harder materials which is harder. We are using the highest gauge 150, and we are using diamond cone of apex cone 120 degrees at 20 degree, and we are using black scale and or C scale. Thus, we will select the weight of the whether weight to be applied on the indenter, the type of the indenter, and type of the scale we are supposed to use. All three parameters are determined as per the material we want to check on this machine itself. There are also other test specimen 15 kg, the diamond 120 15 Rockwell 15 ton, 15 Newton, 30 Newton, 45. So many different things, but we have only the first three. And so many different dial load is available in local testing machine, but we have in our machine only the first three. Now, first of all, we have to clean the surface of the indenter fixing area and clean properly. And before the diamond holder, indenter must be settled indenter up to the neck and threatened cinder to be inserted into the neck hole, and it is to be tightened. It's a crab screw is there on the side. It is to be tightened by slight pressure with Allen key. The text box thickness is generally around 5 millimeter or around 6 millimeter and not more than that. And text box comparatively smaller in size and diameter is around 5 centimeter or 50 millimeters. So it is not as big as vinyl harness testing machine because it's load carrying platform is comparatively smaller in diameter. There is a for protection of main screw, a rubber below is there to protect it thoroughly, which in our machines is torn out due to in certain places. How to operate the machine? Just I have shown you in the video. First of all, we adjust the weight on the plunger of the dashboard according to the local health mentioned in the chart. You have to select the weight on the chart and moving the knob on the chart. It's knob in front of the inside of the machine. We'll set the chart either 60 or 100 or 150 and so. And in these places, the load is totally released by moving the moving the lever left in the leftwise, moving the load actuating lever leftwise, so that you can safely all the dials we can safely set. Now, position A means the side, left hand side position of the dial, then placed second the specimen securely on the testing level. The contact surface should be cleaned and free from foreign matter such as dirt and oil dust, etc. Now, the thickness of the test piece should be at least 8 times for the permanent indentation of the depth. Depth, whatever be the depth, the eight, it should not be the thickness of the test piece should be at least 500 8 times more than that. Otherwise, this indented load will be come out from the bottom, and your reading will be wrong. The distance between the center of the adjacent indenter should be around 4 times the diameter, around 1 centimeter or so. Should not be closer than that. And adjust roughly the setting on the dial. As now we are supposed to move this load carrying platform up by moving the rod in anti-clockwise, moving the rods in anti-clockwise direction, and we'll start that the bigger indenter on the dial it starts moving, and smaller indenter in the dial is also moving slowly. Billet interval will go on at least two complete rotation and will settle on the topmost position where there is a set value is set, the rating set is taken. And next, and the lower lower indicator is will set to the bolt red point, so that when a bigger indenter is on set, a lower and smaller indenter red point, then we say that machine is ready for hardness testing. Next, we have to turn the wheel anti-clockwise so that the specimen will push the indenter and showing a reading on the dial gauge as pointer 3, red spot, and long pointer reaches the position. Turn the lever from this position AP2 slowly so that the load is brought back to the action without any jar. The long pointer reaches a steady position, then indenter is complete. Then take back the lever for a position again. After indentation is complete, so for a few seconds we kept it there and release the indenter by moving the rod in the anti-clockwise direction. It will give you the final and accurate reading of the concerned test piece itself. This has been done that due to the fact that under the action of the load, there are a few items in between the load and the workpiece itself that say plunger rod, plunger pressing point, and over there is a fixing position. All these things will be underloaded, and if you load, and it will press the indenter pointer to a certain distance. When you release all the loads, pointer distance is totally free from our externally applied load, and it will go to the actual point. That's why we take back the leader to a position safely. Check on the proper information. The accuracy of the tester can be verified by means of standard hardness test blocks. And this is supplied here. There is known hardness. And if you check this block with the proper proper indenter as well as proper weights as per the specification of the given in the machine, you will check you will calculate, you can able to measure the indent created on the text piece, and which will match to your find indenter itself. That's why it will prove that your working procedure is correct. Actually, the indentation of the first optimized blocks, actually two or three readings are cancelled, and from third to fourth, we take the readings and we get the indenter. We'll get the diameter. Well, I mean the hardness of the material itself. That chart which is set on the side of the table is given here with certain difference. Here, all the applications are given. What is the hardness value available here, supposed to be here, is given here, and working range is 40 to 90 kg, 330 to 100 kg, and so. This is the working weight given in the machine itself. And here the indenter we are choosing diamond cone, steel ball, diamond cone, etc. And the load given for this indentation is 60, 70, etc. And here the dial selected is black, all everywhere is black. And here selected the type of indenter as per the type of rod machine materials which we are checking their hardness. There's so many different type of ball and different size of the ball and pyramid, diamond pyramid is given, which are not don't have so many things. This is totally covered all sort of different type of machine by providing the right side of indenter ball, providing the scale and providing the weight of the machine concerned itself, which is supposed to be applied here. Mm. Now, this is the full chart. So many different items of different things are given here. And this is a schematic sketch of the Rockwell hardness testing machine. This is the type of type the different loads are fixed inside the machine, which some of them with other loads there are three pillars, all cannot actuate at a time. One will actuate at a time, twice will actuate at a time, and three will actuate at a time and get the full load on the indenter planter itself. So we have seen the Rockwell hardness testing machine itself in the practical case. What we are supposed to do, what is the working instruction, what is minor and major load, what is the principle behind this inspection, what is the benefit or demerits, what is the description itself, size of the machine, this is given. Next, how we will select the indenter and the load of the workpiece itself. How we select the indenter and how we select the load we are supposed to apply to the indenter itself. There are so many different types of indenter is shown here. There's 60, 100, 150, and 187, 120, etc. Here also 147, 264, 240, 444, etc. The what is the working load we have to select from the machine which is given. So three inputs we have to give: load on the machine, the type of the indenter, and type of the workpiece from the workpiece of the metal whose hardness you are supposed to check. And other processes same. We have to rotate the rod in clockwise direction. You first touch the indenter with the test piece. Then test piece will move up again by clockwise direction of the handle of the screw jack lifting platform. And unless both the dials in front of the machine reaches the value 0 for the bigger dial and reaches the point red point for the smaller dial. When after giving the load for few minutes, when you apply the load by moving the actuator load, this load will start indenting in the workpiece and dial gauge will come down as if it is being released, and ultimately it is fixed at a certain point, and from where we release the load actuating box, then dial gauge moves again and start to reduce some of your forces shown there. So and after the hardness is checked, you can keep. So every type of so many different types of metal, so many different types of metals are available in the Indian industries, and almost all can be checked with the hardness, with proper size and proper dimension, keeping the proper dimension intact. Okay, so much for your third experiment, Rockwell hardness testing machine, and in the next class I'll go for the figures. Okay, thanks for your patient hearing and thanks for coming.